Hello everyone, Jake here with Unreal RPG Mastery. Welcome to the Advanced Combat section. We will be covering more advanced combat topics such as a state manager system that will support and manage multiple character states, multiple attack types such as strong attack and charge attack. We will cover action priority and a bit more about hit reactions. In this video, we're going to implement multiple character states. Right now we already have multiple character states. We have attacking, dodging, death, and toggling combat. However, we are doing this with booleans. The reason we set character states up with booleans is so that I could show you how much neater things are when we implement a character state's enum. If, for example, you need to do some check based on the character state, you're going to need to do something like this. I'm just going to create an example custom event here, and let's say dead has the highest priority, so we want to check dead first. If the character is dead, we do something. I'm just going to call print string here. If dead. If the character is not dead, we may need to check, is the character disabled? That's the next highest priority to check. We'll just say, if disabled. Then we get the combat component, is attacking. If attacking. And then we add another check. We check, is the character dodging? If the character is dodging, we say if dodging. And after that, we do another check, is the character toggling combat? As you add more states to your game, this will become a huge chain of if-else statements. If you want to check and run different kinds of code based on what state the character is in, you would need to go through and check every boolean until you find the one that you're looking for. This will force us to do a bunch of checks that we don't really need to do. And normally if you see something like this, there may be a better way. Now sometimes you have to do nested if-else statements. Nested if-else statements are a programming tool and it does have its uses. However, in this scenario, a cleaner way to do this would be to use a switch statement. A switch statement is much cleaner and will only run the code that we need to run. We don't have to check a bunch of other conditions. For this we can use an enum instead. The enum also makes things more human readable and easier to extend in the future. So let's go ahead and create our character states enum. Let's go to blueprints, enums, and here under blueprints, let's create a new enumeration. We'll call this one e_character state. Okay, open it up. And all of these character states that you see here, we just need to add those to the enum. So far we have 5 states, but let's add 6 enumerators. Okay. And the reason why we added 6 is because the first state is going to be nothing. The nothing state is going to be the character's default state. So by default, the character is doing nothing. And after a character finishes an action, he's going to go back to the nothing state. I'm going to add attacking, dodging. Okay, and this one will be general state. This general state will be for actions that don't necessarily need its own state. We could even call this one general action state. And this one's going to be dead. This one's going to be disabled. Okay, now that we have that, we can do a switch on character state. And now a switch statement will automatically call one of these based on the input value here. So if the input is attacking, it'll run the attacking execution pin, and so on and so forth. So now you could do that same thing, except now it's much cleaner. This is a whole lot easier to manage as well. Because in this scenario, if the character is toggling combat, we'd have to check, is the character dead? Is the character disabled? Is the character attacking? Is the character dodging? And then finally get to, is the character toggling combat? But in this scenario, we can just check, is the character performing a general action? If he is, we just go straight to this execution pin. So now let's put this to use by creating the state manager system. A state manager is a common technique used in programming to manage different states of an object. In this video, you will learn how to create a state manager, and you will also learn how powerful a state manager can be. We are going to start by creating a state manager component. Let's go to Combat System, Blueprints, Components, right-click and select Blueprint Class. We're going to need to create an actor component. We'll call this actor component BP_state manager component. Okay, now open it up. This component will be fairly simple, but really powerful. So the first thing that we need to do is create a variable. We'll have this of type character state. Call this one current state. For our current state variable, let's go ahead and utilize encapsulation. So let's make this private, and we'll create a new function, set state, and also get current state. For get current state, we need to return the current state. We also need to make that a pure function. Okay, and for the set state function, we need to plug this in as an input, except instead of current state, we'll call this new state. And we could just directly set the state here, but we don't actually want to do that. Okay, and now let's create a couple event dispatchers. The first one will be onStateBegin. And for an input, we're going to add the character state. And this other one will be onStateEnd. We'll create an input, and that'll be the character state. Now drag both of these dispatchers into the setState function and call them. Okay. So how do we detect when a state ends and when a new state begins? An easy way to do that would be, let's go ahead and unplug this. We get, is new state not equal to current state? If new state is not equal to current state, then we are going to end the current state. And then after that, the new state will now be the current state. Then after that, we call onStateBegin. And this is a fairly simple setup. We just check, is the new state not equal to the current state? If that is true, then we must be setting the character to a new state. So then we call onStateEnd. And after that, we get our new state and set that as the current state, and we call onStateBegin. Okay, now we need another new function. We'll have this one as resetState. And whenever we reset the state, we're simply going to set the state to nothing. Another useful function would be to check if the current state is equal to a list of states. So we can call this function, is current state equal to any? And as an input, we can add an array of character states. We can call this one states to check. This function is going to be fairly simple. All we need to do is check if the array contains the current state. And then after that, we simply return the result. Go ahead and make that a pure function. Compile and save. And there is our state manager system finished. It's a fairly simple system, but it is very powerful. Let me show you how useful a state manager can be. So let's go to our combat player character. Let's add our state manager. Okay, and similar to what we did with the collision component, we can also add onStateBegin and onStateEnd events for our dispatchers. Okay. And let's move character states down here and expand this out to be larger. And move this down here. Okay. And so now what you can do is onStateBegin, you can add a switch statement, and onStateEnd, you can add a switch statement. And you can basically fire some code based on which state you enter and which state you end. If your character is going between states and you just set certain things on in a certain state and set it off when the state ends, this is a really good way to manage that. It's a really clean and powerful way to manage multiple character states, because as soon as the character enters a state, the code associated with that state will run. And as soon as the character leaves a state, it will run this event, and you can set anything off that you need to. And so let's say, for example, there's a state where the character needs to go into flying mode. Well, onStateBegin, you could set the character into flying mode, and onStateEnd, you could send it back to normal, which will automatically be handled for you by your state manager. We can also use our state manager system to decide when the character can and can't perform actions. So we can use the state manager to clean up a lot of this code. So let's drag in our state manager component. We can say is current state equal to any. We'll have an input states to check. We can just make that into an array. And we could just add a not boolean here. And we can check, is the character not attacking? Is the character not dodging? Is the character not dead? Is the character not disabled? Is the character not performing a general action? If the character is not doing all of these things, then he can attack. We could just add an and boolean here. You also need to check, is character not falling? As you can see, this is much cleaner and easier to manage. If you want to add a new state, you simply just add a new state. I'm just going to call this example state. And let's say you don't want the character to be able to attack while he's in the example state. You just go here, you add a new pin, and you add example state. This makes it really easy to add new states and manage when the character can and can't perform actions, and manage code that sets on and off depending on the state. So you can go here to event graph, and you got your new example state here, and you can just add code. Whenever you enter the state, you fire some code here, and whenever you end the state, you fire some different code. Okay, now let's update our other can perform actions. Now let's go ahead and remove the isAttacking boolean from the attack combo system. Let's open up the combat component. We do not need isAttacking. And here you can get state manager component, get current state. Is the current state equal to attacking? And you can do the same thing here. If the character's current state is equal to attacking, then you set state to nothing. Okay, now whenever we perform an attack, we want to remove this, get the state manager component, and we need to set state. We'll set the state to attacking. Okay, now open up the perform dodge function, and we need to delete dodging. Get our state manager component, and we can set state to dodging. Set state, dodging. Compile and save. Okay, let's set our state here for toggle combat. Toggle combat doesn't necessarily need its own dedicated state, so we can just set the new state to general action state. Okay, whenever the character takes a hit reaction, you can set the character state to disabled. Okay, and on combat reset, we can remove all these booleans. We can get the state manager component and simply call reset. Okay, and something else that we can do is instead of perform death here, we can get the state manager and set the state to dead. And here on state begin, on the dead state, we can just perform death. We don't have a resurrection mechanic or anything for this system, so we don't need to add anything for on dead state end. And something else that we need to do is update the can receive damage interface. So we need to get the state manager component, get current state is not equal to dead. Okay, we no longer need this is dead boolean. And we can go ahead and delete all these booleans now. Okay, and now the state manager system is finished and fully integrated into our character blueprint. Let's test out the gameplay and see if everything still works. So all the actions seem to be working. So it seems like we're having an issue with character death. The reason why this bug is happening is because we set the character state to dead first whenever we take damage, then afterwards we set the character state to disabled. So basically what you need to do is create a condition check. So similar to can jump, let's create a duplicate, call this one can receive hit reactions. Okay, and what we're going to do is, let's remove all of these pins, except for dead. And now, the character cannot receive hit stun if he's dead. Okay, and now the character cannot receive a hit reaction if he is dead. Okay, let's test that out and see if it works. And that has fixed our issue. That brings us to the end of this video. We have created a character state enum, a state manager system. We have gone over what a state manager system is, what makes them so powerful. We have implemented the state manager system into our character blueprint and ensured that all the bugs are now resolved. Thanks for watching. In the next video, we're going to look into multiple character actions.